Hello, today we're looking at a simulation for molecule shapes. So we could either choose to look at a model of a molecule or look at some real molecules, but we'll start off looking at a model. So the simulation is really simple and easy to use. We can click anywhere in the model area to rotate our molecule. We can click on atoms and rotate the molecule like that. Over here in this box to the right labeled bonding, we can choose to add more atoms to our molecule simply by clicking on them. We can only add up to a total of 6 atoms to our molecule. This little red X allows us to remove them. In the box below that, we can add some lone pairs to our molecule. Again, we can only add a total of up to 6 lone pairs or atoms. The button below that removes all atoms and lone pairs from our central atom. So let's add 2 bonded atoms and 2 lone pairs. Right here you see in this options box we can choose to either hide or show lone pairs, and we can choose to show bond angles or hide them. So let's show them for right now. In this box to the left we can choose to show molecular geometry, which in this case is bent, and we can also show electron geometry, which in this case is tetrahedral. This button on the right here, this resets our simulation to where it began. So let's add 3 more atoms to this, because one thing I want to note is that you may have to rotate your molecule to see some of the angles. So right here from this angle we can only see the 90-degree angles, but if we rotate it down this way we can see the 120-degree angles. So that's enough of the model. Let's start looking at some real molecules by clicking down here in this real molecule box. So right here we're given an H2O molecule, and we can rotate it just as we could with a model. And again, we have the options to show or hide the lone pairs, and show or hide the bond angles. So we'll leave both of those showing. Down here at the bottom left, we can choose to show the molecular geometry, which is bent for H2O, and the electron geometry, which is tetrahedral. Up here at the top, we have 2 buttons. We can click to show a model of the molecule we're looking at, or look at the real molecule. Notice that if we click on model, it gives an idealized angle between the atoms, and if we click on real, we get the actual angle that we would have between the atoms. Now over here at the top right, we can choose from 13 different molecules to look at. So let's look at some of the more interesting molecules, such as ClF3. You can see we have a T-shaped molecular geometry. We have SF4, the seesaw geometry. Notice that we may have to rotate the molecule to get a good look at the bond angles. And PCl5, the trigonal bipyramidal geometry, and SF6, an octahedral geometry. Overall, I think the simulation did a very good job. It'll definitely help students, especially in freshman chemistry, who are just going over Vesper rule and going over different molecular geometry to visualize the 3-dimensional structures that they're dealing with. That can be rather difficult from working on paper. So I think this simulation helps to visualize it in a 3-dimensional aspect. There aren't very many negative things about the simulation. I think the only downside to the simulation is that we are limited to 1 central atom and only up to 6 bonding atoms. But other than that, there are no real negatives to this simulation. I would definitely recommend this to any students who are struggling with visualizing 3-dimensional shapes in their chemistry classes.